Today we're going to look at difference of perfect squares. That is, a squared minus b squared will be equal to the factorized form of a plus b multiplied by a minus b. And a and b are real numbers. Let's apply this to a problem which may look very hard at first, but once applying this relationship is actually quite simple. 123,456 squared minus 123,457 multiplied by 123,455. And what we notice is that 123,457 is just 123,456 plus 1, and the same as 123,455 but minus 1. So let's just represent them as those expressions. 123,456 plus 1, 123,456 minus 1. Now, from the difference of perfect squares relationship, we already know what this answer is going to be. 123,456 squared minus negative 1 squared. But we'll just prove it to you by expanding it. So, yes, that will stay as normal, and we are going to multiply, obviously, using FOIL, the first term in the first bracket and the second term in the second bracket. That's going to be 123,456 squared. Let me just write that for a bit better. Squared. Now what we're going to do is multiply the second terms, which is just going to be obviously 120,456 times minus 1, which is just minus 120,456, and the opposite with the positive 1, 120,456, then the positive 1 times negative 1, which is negative 1. Minus 1. Okay, now we can just cross out the negative 123,456 and the positive 123,456. Just cross them out. And we are left with 123,456 squared minus 123,456 squared. Let me just draw the other bracket. There we go. Minus 1, obviously, because you're left with minus 1. But remember this, to open the brackets, there's a negative sign in front of it, and we know that's an invisible 1 there. So the 123,456 will be staying the same, but we will expand the negative 1 times 123,456 squared minus 1. So that's going to just be minus 123,456, because a negative times a positive is a negative. Negative times a negative is a positive, and negative 1 times negative 1 is positive 1. So we can cross these 120,456 squared because they will just equal 0, and we know the answer of this long problem is just a simple 1 using the difference of squares. Let's find a more algebraic example which we can apply pronumerals or variables to it to actually find the answer. 2002 squared over 2001 squared. These problems are all in Terry Chu's book. 2 plus 2003 squared minus 2. So if we notice, let's just set 2002 as A. What we notice is that 2001 is just a minus 1, and 2003 is a plus 1. So let's replace those expressions instead of these numbers, because if we do get to cancel out, then we know that's just going to be the answer for the numbers in the problem, because cancelling out works the same way. So let's just do a squared over a minus 1 squared plus a plus 1 squared minus 2. Using our multiplication of polynomials, we can expand those in the denominator pretty fast. A squared minus 2a plus, because negative times negative is positive, 1 plus a squared plus 2a plus 1 minus 2. After we do the cancelling out and simplifying in the denominator, we get a squared over 2a squared. We know that there is a 1 in front of the a squared, so we can cancel out the a squared, and we are left with a half, which is going to be the answer to this rather complicated problem.